Hello and welcome to my video report of Lab 1, where we looked at charged tapes and their interactions with both charged and neutral matter. In this lab, we were asked to create U-tapes and observe their interactions, determine the charge on a given U-tape, calculate the fraction of atoms which release an electron, and create a computational model to determine the charge of a U-tape and the electric field it produces. First, we looked at the interactions of two charged U-tapes. A U-tape is created by quickly peeling one piece of tape off of another, causing one of them to leave behind some electrons. This absence of negatively charged electrons causes that piece of tape to gain a positive charge. In this first experiment, we held two charged U-tapes in close proximity. My expectation was that as both tapes were created in the same way, they would either both be positively charged or both be negatively charged. Either way, this would cause the tapes to repel, and after performing the experiment, this was in fact the outcome. Next, we looked at the interaction of a single charged U-tape and neutral matter, such as the book seen here. From our knowledge of polarization, the expectation here is that the charged U-tape will cause the molecules in the book to polarize in such a way that the charged tape will be attracted to the neutral matter. In performing the experiment, we saw that this is what happened. We then needed to determine whether the tape was positively charged or negatively charged. To do this, we created a negative charge using a clear plastic pen by rubbing the pen with wool. As we know the pen has a negative charge and the tape was attracted to the pen, we can determine that the tape was positively charged. Following this, we looked at the floating tape experiment. The idea here was to make a positively charged U-tape and place it resting on two books. We then take a second positively charged U-tape and hold it underneath, causing the first piece of tape to float in the air. After many tries, I got this experiment to work and recorded the relevant information. The tape which was suspended had a length of 27 centimeters, and using the fact that a meter of tape has a mass of 1 gram, we know this length of tape has a mass of 0.27 grams. The distance between the two charged tapes during the suspension was 0.6 centimeters. Using the data recorded from our experiment, we then had to calculate the charge of one of the U-tapes. As the tape was held motionless in the air, we know that the net force acting on it was 0. As the only two forces acting on it were the gravitational force of the Earth and the electric field of the other U-tape, these forces must sum to 0, as we can see in our free body diagram. Modelling the tape as a point particle and assuming the U-tapes have equal charge, we're able to use the equations for electric force and gravity as seen here. We can rearrange for Q, which equals the square root of 4 pi epsilon 0 times the separation squared times the mass times little g. Using the relevant values obtained from the experiment, we can determine that Q is equal to 3.25 times 10 to the minus 9 coulombs. Comparing our results with the output of the computational model, we can see that we have the same value for the charge on each tape, and in addition to this, using the electric field function we created in Lab 0, we can see that the electric field at the location of the floating tape from the tape underneath is equal to 8.13 times 10 to the 5 newtons per coulomb in the positive y direction. We can also see that our models look just like our free body diagram. We also performed some calculations to determine the number of atoms which lost an electron and the ratio of atoms which lost an electron. As we can see here, by dividing the total charge on a U-tape by the charge of an electron, we get the value of 2.03 times 10 to the 10 atoms which are electron deficient. By calculating the surface area of the tape using its length and its width, which I measured to be 1.9 centimeters, and by calculating the surface area of an atom, we were able to calculate the number of atoms on the surface of a tape. Then, by dividing the number of electron deficient atoms by the total number of atoms, we got the ratio of atoms which are electron deficient. As you can see here, it is far less than 1%. Lastly, we needed to answer a couple of final questions. The first of which asks what would happen if electrons and protons change charge. Nothing observable would change besides the tape being repelled by the plastic pen. In the experiments where the U-tapes have a like charge, the U-tapes would still repel, and in the case where the U-tapes interacted with neutral matter, it would still polarize to be attracted. The final question asked why we had to be careful handling charged tapes. This is simply because the charged tapes discharge when being held. Our hands are conductors due to the layer of moisture on our skin, And this is the same with many other objects. Even if they are insulators, the moisture in the air will slowly discharge the tape. This concludes my report for Lab 1. Thank you very much for listening.